Welcome, guys. This is the APES Chapter 12 lecture. We're starting out talking about fracking for oil and gas. We've done a lot of research into this. But essentially, what we're talking about with fracking is trying to increase our fossil fuel reserves and trying to prolong our fossil fuel reserves. We're trying to become more energy independent because we have huge reserves here in the U.S. So there definitely are a lot of positives to fracking. There are for sure some negatives. So it's one of those things that we definitely need to find a way to use. We definitely need to find a way to monitor it and things along those lines. So this picture I flipped to a little bit too quickly, but you're seeing the strategy behind fracking. It's going to be horizontal drilling. We're going to drill down a ways, way below the aquifers, and then we're going to horizontally run pipe so that we can harvest a wider and a longer seam. The natural gas sometimes is trapped in pockets, as you know, so we want to be able to capture as much of that as we possibly can, and a vertical shaft just wouldn't be as efficient. And then you see that even lower there may be deposits of oil in shale rock. So we'll look a little bit more at those later. That's really an emerging fossil fuel source. So that's sort of, like I said, we'll get to that. So net energy is a really big idea here in APES. And it's the idea of how energy positive is the energy resource. Something that has a lot of useful energy is going to have a really positive net energy. Something that kind of costs more to burn than you get out of it is going to have a negative net energy. So basically, we're trying to figure out how sustainable is this energy source. Like it says here, if the net energy is zero or negative, then it can't compete in a free market, so we're going to need subsidies from taxpayers to make that energy source viable and to make it usable. Moving on to 12.2, advantages and disadvantages of fossil fuels. Well, there are tons of each. So make sure you understand this crude oil term. That's one that we've been misusing here over the last week or so. So conventional crude oil is abundant. There is a lot of conventional crude oil. It does have a medium net energy. It doesn't have a great net energy because of what it releases. You see that there. It causes water pollution, releases tons of greenhouse gases. We do have heavy oil from shale rock and tar sands. That's sort of what I talked about a few slides ago that we're just now tapping into. But both of those have a low net energy and a high environmental impact, even higher than that of conventional oil. So definitely not something that environmentalists want to pivot towards. Kind of like we talked about natural gas. Maybe it's a bridge to sustainability, but that's not a road that we want to go down because of the heavy environmental toll that it has. So we are dependent upon oil. Specifically oil in terms of fossil fuels. So crude oil has to be processed somehow, some way. That's this point right here. Lots of us have been using crude oil incorrectly. So make sure that when you say crude oil, you mean crude oil, the stuff that comes out of the ground. It's not something that we can put into our gas tank or put into a coal-fired plant or something along those lines. Vocab term there, peak production. All of these types of harvesting are going to have peak production, and then your yield from that well is going to decline after you hit that peak production, which I think probably makes sense. Now, I know this picture is relatively small, but what we're looking at here is how we process oils and how we refine crude oil. Notice that we're going to heat it, and then we're going to condense it. So we're going to boil something, and then we're going to condense it down. The first thing, or the lowest thing that boils, is going to be asphalt, and then as we move up, grease and wax, naphtha, I mispronounce that all the time, diesel oil, heating oil, jet fuel, gas, and then natural gases have the lowest boiling point. I think I said that backwards. These things are going to boil first. These things are going to boil last. So as we heat the oil, then natural gases are going to rise to the top, then the gasoline, then the aviation fuel, and it's going to fill down to where the heaviest things are near the bottom. So a couple ideas here that are important. Proven oil reserves are going to be how much is in the ground, like how much can we pull from the ground. You see some of the things that influence how productive that can be or how profitable it can be. Demand, of course, technology, how fast are we removing the oil, how expensive is it to process it, and what's the market price. Think about OPEC there. We looked at how OPEC sets prices, and that certainly manipulates how much of our oil supply we're using. So evidence shows that we are running low. We are we're operating in the negatives. So we need more oil. So how can we do that? How can we increase our oil supplies? One, we could use that unconventional heavy oil I talked about earlier, tar sands and shale oil and things like that. But they do have a lower net energy, so we're not going to get as much bang for our buck, and they have a higher environmental impact. So two pretty strong negatives. So then our other three options are either deal with higher oil prices, and maybe fewer of us can afford to drive and things along those lines. Extend oil supplies, so be more efficient with the way that we use oil, or use other energy sources. And we'll talk more about that in our next chapter. But what you're looking at here on the screen, here are our oil reserves. So Venezuela has a strong amount of oil reserves. Notice Saudi Arabia has pretty high relative oil reserves, but they're also producing it really fast. So they're pulling the oil out of those reserves faster than, say, Venezuela. Venezuela is not top 3 in production. So they've got a larger reserve. They've got a longer supply of crude oil. And then down here, oil consumption, of course, the U.S. is the number 1 consumer. China's number 2. But notice we do produce, we have increased our production gradually over time. So advantages and disadvantages to crude oil. We do have enough for, I've seen 50 to 100 years. Does have a medium net energy. Doesn't disrupt a ton of land compared to some other strategies of generating energy. And it is somewhat efficient. Again, it has that medium net energy. Disadvantages, we've looked at lots of those. Pollution from leaks and oil spills and air pollutants. And then, of course, we're dependent upon foreign countries because we only produce a small percentage of what we use. So, is natural gas better? Maybe coal isn't great because, maybe petroleum isn't great because we don't have a huge supply of it here in the U.S. Maybe natural gas is better. Maybe we can frack that natural gas that we do have here in the U.S., and that has more advantages than disadvantages. Notice that natural gas, when we say natural gas, we're talking about a mixture, typically 50 to 90% methane. We do have more of it. We can do a lot with it. It has medium net energy again, and a low production cost, and it's cleaner burning than is coal. It's cleaner burning than a lot of other fossil fuels, petroleum, things like that. We produce natural gas conventionally and unconventionally through fracking. Notice that a lot of times we have natural gas deposits directly above crude oil. Sometimes it's going to be packed between layers of shale rock. That's when we're going to need to frack it. When it's above, like picture a cave that's full of crude oil. Over time, that crude oil is going to decay. That crude oil maybe is going to heat up and evaporate, something like that, and that's going to turn into the natural gas. That's not 100% accurate, but I think that gives you a visual to think about as you consider natural gas production. Propane and butane, we call that LP gas. That's what I use to heat my home, the big gas tanks that look like Tylenol or something like that. They're full of LP. Then the remaining gases are, of course, purified, filtered, processed, and pumped into pipelines and delivered over land and sea as LN gas, which stands for liquefied natural gas. So it's just a better way to ship it from place to place. So we know a lot about fracking. We're going to drill wells. We're going to use a lot of water and sand and chemicals. We're going to cause micro earthquakes. We're going to cause that natural gas to escape, and then we're going to try to catch it. There is some evidence that it leads to increases in earthquakes, particularly in Oklahoma. We're seeing lots of that. We've seen examples of polluted wastewater and gas contamination in water. We definitely are seeing methane emissions and things along those lines. So think back to the movie Gasland, and I think all that will ring true. Similar graphs to what we saw before, but instead we're looking at natural gas. So notice U.S. is the leader in natural gas production, and we're the leader in natural gas consumption. So that's good. We're not dependent upon some of these countries up here that maybe we don't want to be dependent upon, and these countries here as well that we don't want to be dependent upon. Of course, it has advantages and disadvantages. Some of the advantages are that we do have a lot of it. We can do a lot with it. It does have that medium net energy, and it's cleaner burning than some of the alternatives. The liquid gas, natural gas, that decreases our energy efficiency because of things like the fact that we have to move it around. It takes energy to convert it from gas to liquid and then back to gas and so on. So there definitely are some really big disadvantages. So what about coal? Coal, like I said in class, is fossilized remains of plants buried and exposed to intense heat for a really long amount of time. They're solid fossil fuels. It is our most abundant fossil fuel, and it generates 40% of the world's electricity, and even a higher number here in the U.S. Again, I know that my picture is small, but what we're trying to show here is how we create coal. I'm going to really emphasize this whole year, this is the key. We're just trying to figure out how to turn a turbine. If we can turn a turbine, we can generate electricity and we can transfer it out. To get to that, we bring in coal, we shake it, we try to clean it up as best we can, then we burn it. When we burn it, we're going to have some ash that's left over. Think about any time you've had a campfire or anything like that, there's always ash left over. That's our organics burning off. The fire is going to burn the coal. It's going to heat up water. Water is going to turn the turbine. Then we're going to have to cool down that water. That's what these big smokestacks are. They're called cooling towers. You see a lot of those near Terre Haute if you drive south and west of here. Then back here, the turbine turns, the generator turns basically and creates that electrical current, which then travels through the electrical wires to your home. Coal's dirty. Lots of sulfur released as SO2, large amounts of soot, tons of carbon dioxide, tons of coal ash that you then have to truck away and store somewhere. Lots of costs in terms of harvesting coal, lots of costs in terms of processing coal, all those types of things. Here's our graphs that show our reserves. We're really high, so that's a good thing for us. We have less production than does China, and we consume a lot less than does China. So that should probably match up. If you compare the graphs of natural gas, it would look really similar, or I guess exactly opposite, where we have a lot of natural gas and we use a lot of natural gas. They have a lot of coal, so they use a lot of coal. Ample supplies for sure, medium to high net energy, low cost when you don't include the environmental and the health costs, but when you do, that really drastically increases the cost of coal when you incorporate asthma rates and the impact to the folks at the extraction points and those types of things. Does disrupt tons of land, particularly if you use mountaintop removal mining, pollutes tons of water, lots of negatives, mostly involved around mining and burning the coal. So the next flip, we'll talk about nuclear energy. Definitely some positives and some negatives there, but that's the end of part 1.